Have you ever held two magnets in your hands, felt their unseen forces push and pull, and wondered, why is this happening? Welcome to the captivating world of magnetism, an enigmatic force that permeates our universe. Today, we're going to try and unravel this mystery, one magnetic field at a time. Magnetism, in essence, is a force of attraction or repulsion that acts at a distance. It's one of the fundamental forces that hold our universe together, right alongside gravity. It's an invisible power that we can't see or touch, but we can certainly feel and observe its effects. Take, for instance, two magnets. When you bring them close, they either attract each other or repel, depending on their orientation. This behavior is due to the inherent properties of magnets. Each magnet has two poles, a north and a south. Like poles repel each other, while unlike poles attract. This is one of the fundamental laws of magnetism. But the magic of magnets doesn't stop at mere attraction and repulsion. They also create an invisible field of influence around them, known as the magnetic field. This field is what enables magnets to interact with each other without physical contact. Imagine it as an invisible aura that extends all around the magnet. The strength and direction of this field vary with the distance from the magnet, and it is this field that other magnets or magnetic materials feel when they come close. The magnetic field is not just limited to magnets, though, it's all around us. The Earth itself is a giant magnet, with its very own magnetic field enveloping us. So, we've seen how magnets attract and repel and create invisible fields of influence. But what causes magnets to behave this way? What is the secret behind this mysterious force that we call magnetism? Well, the answer lies in the very building blocks of matter, the atoms themselves. But that's a story for our next scene. So magnets attract and repel, but what causes this invisible force? Let's uncover the secrets. The secret of magnetism lies in the microscopic world of atoms. Now, if you're not a fan of the tiny, invisible world, don't worry. We're going to make this as clear as a summer's day. Atoms, those tiny building blocks of everything around us, are the key players in our magnetic narrative. Think of an atom as a miniature solar system. At the center, we have the nucleus, acting like the sun, and around it, electrons orbit, similar to planets. But here's the kicker. These electrons aren't just orbiting, they're spinning too. Imagine them as tiny tops whirling around at breakneck speeds. This spin creates a small magnetic field around each electron. Now, in most materials, these miniature magnetic fields are like a room full of tops spinning in different directions. They cancel each other out. There's no particular alignment, no order, and as such, no noticeable magnetic force. It's a bit like a choir where everyone's singing a different song. The result is just noise, not music. However, in some materials, something extraordinary happens. The electron's spins align. The tops start spinning in the same direction. This alignment creates a larger magnetic field, a force that we can actually feel and see in action when we stick a fridge magnet or use a compass. But what causes this alignment, you might wonder? Well, it's down to the structure of the atom itself and the way electrons fill the atomic shells. In certain elements like iron, nickel, and cobalt, the filling of the electron shells results in a lot more top spinning in one direction than the other. It's like a choir suddenly finding the right tune and singing in harmony. So, in essence, magnetism is the symphony of atoms playing in harmony. It's a beautiful, invisible force that permeates our universe, from the smallest atom to the largest galaxy, and it's all thanks to the secret dance of the electrons. Did you know we all live on a giant magnet? Surprising, isn't it? But it's true. Our Earth, this colossal planet we call home, is essentially a massive magnet. It's because of a phenomenon known as Earth's magnetic field. This magnetic field is an invisible force that extends from the Earth's interior out into space. It's created by the molten iron that whirls within Earth's outer core. As this molten iron moves, it generates electric currents, which in turn produce our planet's magnetic field. Now you might be wondering, why does this matter? Why should we care about this invisible force field? Well, the Earth's magnetic field plays a crucial role in protecting life as we know it. You see, our planet is constantly bombarded by the solar wind. This is a stream of charged particles emanating from the sun. Without the Earth's magnetic field, these particles would strip away our atmosphere, leaving the planet barren and lifeless. But thanks to our magnetic shield, these particles are deflected, protecting us from the sun's potentially devastating effects. But the magic of Earth's magnetism doesn't stop there. It's also responsible for one of the most ethereal natural phenomena, the northern and southern lights. These lights, also known as auroras, occur when the solar wind particles interact with the Earth's magnetic field. As these particles collide with our atmosphere's gases, they create vibrant, dancing lights in the sky. So, whether it's the breathtaking spectacle of the auroras or the invisible shield protecting us from the solar wind, the power of Earth's magnetism is truly awe-inspiring. It's a force that silently shapes our world and our experience of life on this planet, even though we may not always be aware of it. So, our very survival depends on this magical force called magnetism. From the invisible threads that link the Earth's core to the cosmos, to the mesmerizing lights that dance in our skies, magnetism is a fundamental part of our existence and a testament to the untold wonders of our natural world. Ever wondered how a compass works? Let's unravel this mystery together. The compass, a seemingly simple device, leverages the Earth's magnetic field to always point north. But how does it do that? You see, our Earth behaves like a gigantic magnet, with a magnetic north and south pole. When we place a compass in this magnetic field, the needle, which itself is a tiny magnet, aligns itself with the Earth's magnetic field lines. That's why the needle always points towards the magnetic north. But remember, magnetic north is not the same as geographic north. The difference between the two is called magnetic declination, but that's a topic for another day. This principle of the compass has been a cornerstone for navigation for centuries, guiding explorers across uncharted territories and oceans. So magnetism isn't just fascinating, it's been guiding us for ages. Now, isn't that a direction worth following? Magnetism is not just a natural phenomenon, but a critical component of modern technology. Let's delve into the profound influence of magnetism on our everyday tech devices. In this digital age, electronics are ubiquitous. From the smartphone in your pocket to the computer on your desk, these devices owe much of their functionality to magnetism. Take the hard drive of a computer, for instance. It's the magnetic properties of certain materials stored in the hard drive that allow digital information to be saved and retrieved. All of the data, from your favorite photos to important documents, are converted into binary code, a series of ones and zeros, and this code is written onto the hard drive using magnetism. And how about the television? While the latest models use advanced technology like liquid crystals or light-emitting diodes, the traditional cathode ray tube television sets function thanks to magnetism. An electron beam directed by magnetic fields scanned across the screen to create the images you see. Yet the influence of magnetism extends far beyond entertainment and personal computing. It plays a significant role in medical technology too. One prime example is the magnetic resonance imaging machine, better known as the MRI. This machine uses a powerful magnetic field along with radio waves to produce detailed images of the inside of the human body. These images are invaluable for diagnosing a wide range of medical conditions, from tumors to torn ligaments, all without the need for invasive procedures. But how is magnetism harnessed in these devices? It all comes down to the concept of electromagnetism. This is the interaction between electricity and magnetism, where an electric current can generate a magnetic field, and vice versa. This principle is used in a wide variety of technology. For instance, in speakers and headphones, an electric current is passed through a coil, creating a magnetic field that interacts with a permanent magnet. This causes the coil to move, vibrating the speaker diaphragm and producing the sound you hear. In electric motors found in everything from electric vehicles to household appliances, the principle of electromagnetism is used to convert electrical energy into mechanical energy. A current-carrying coil in the motor is rotated by the magnetic field produced by permanent magnets, driving the motion of the motor. Across the spectrum, from the devices we use for work and play to the machines that keep us healthy, magnetism is a driving force. The principles of magnetism and electromagnetism have been harnessed to store our data, display our television shows, diagnose our illnesses, and even power our vehicles. So magnetism isn't just in the palms of your hands or the earth beneath your feet, it's in the screen you're watching right now. The secrets of magnetism have been revealed, but what about its future? As we've traversed the captivating world of magnetism, we've seen its profound influence on our lives. Yet the journey is far from over. The future of magnetism is brimming with potential, with promising applications that could redefine our reality. One such application is magnetic levitation, or maglev. Already in use in some high-speed trains, this technology uses magnetism to lift and propel vehicles, reducing friction and allowing for incredible speeds. But imagine a world where maglev isn't just for trains. Picture personal vehicles, cargo transport, even entire cities floating on a cushion of magnetic force. A future where the hum of tires on asphalt is replaced by the silent glide of maglev. And then there's fusion power, the holy grail of energy production. At its core, fusion power relies on magnetic fields to contain and control the plasma where fusion occurs. The science is complex, but the payoff is immense. Clean, virtually limitless energy that could power our world without the harmful emissions of fossil fuels. Magnetism could be the key to unlocking this revolutionary power source. But these are just two examples. The potential applications of magnetism extend far beyond what we can currently envision. Perhaps we'll harness magnetism to develop new forms of communication, or use it to explore the furthest reaches of our universe. Maybe we'll even tap into the Earth's magnetic field to protect us from solar radiation, like a planetary-scale shield. Of course, these are all speculations. The future of magnetism, like the future of any scientific field, is uncertain. But one thing is clear: the potential is there. As we continue to explore, to experiment, to push the boundaries of what we know, the possibilities are endless. Who knows what magnetic secrets we'll uncover in the future? As we delve deeper into the mysteries of magnetism, we look forward to a future filled with discovery, innovation, and the endless potential of this incredible force. So, what have we learned about the secrets of magnetism? We've ventured on a journey that has taken us from the smallest building blocks of matter to the vast expanse of our universe, all woven together by the unseen threads of magnetism. We started our exploration with the enigma of magnetism, a force that has fascinated humanity since ancient times. We discussed how magnetism is a form of energy that is both mysterious and fundamental, and how it's an integral part of the universe's design. We learned how magnetism is not just a physical phenomenon, but a universal law that governs the cosmos. Then, we delved into the atomic secret behind magnetism. It's all about the electrons, those tiny particles spinning around the nucleus of every atom. We discovered that each electron is like a tiny magnet, and when they align in a material, they create a magnetic field. This atomic dance is what gives rise to the force we know as magnetism. Our journey then took us to our own planet, Earth, where we explored the power of its magnetism. We talked about the Earth's magnetic field, a protective shield that deflects harmful solar radiation, enabling life as we know it to exist. We learned how this magnetic field is generated deep within the Earth's core, and how it has flipped its polarity multiple times throughout the planet's history. We also looked at how magnetism influences our everyday lives. We discussed the magnetic field and compass, a simple yet powerful tool that has guided explorers and navigators for centuries. We learned how a compass needle, itself a tiny magnet, aligns itself with the Earth's magnetic field, always pointing us towards the north. Then, we explored the influence of magnetism on technology. We saw how magnetism is at the heart of many modern technologies, from the electric motors that power our appliances to the hard drives that store our digital lives. We learned that without magnetism, our modern world would be unimaginable. Finally, we looked to the future of magnetism. We pondered on the potential applications of this force, from magnetic levitation and transportation to the development of quantum computers. We recognize that our understanding of magnetism is still evolving, and that the future holds many exciting possibilities. Throughout this journey, we've seen how magnetism is a fundamental force that shapes our universe, powers our technology, and influences our daily lives. We've learned that magnetism is more than just the push and pull of a fridge magnet. It is a universal law that governs the cosmos. So next time you feel the push and pull of a magnet, remember, you're experiencing one of the universe's fundamental forces. Did you know that the concept of magnetism can also be applied to our thought processes? Just as magnets have a field of influence, our thoughts and emotions create a similar energy field. This concept is often referred to as the law of attraction, suggesting that, like attracts like in the realm of thoughts and emotions. Think of yourself as a magnet. If you're filled with positive thoughts and emotions, you're more likely to attract positivity into your life. Conversely, if you're clouded with negativity, you may find yourself attracting more of the same. Visualization techniques are often used to magnetize desired outcomes. When you visualize your goals and desires, you're essentially creating a magnetic field of energy that can draw these things towards you. So magnetism isn't just a physical phenomenon, it's a mental one too. Next time you're faced with a challenging situation, remember the power of mental magnetism. By focusing your thoughts and emotions in a positive direction, you can attract the outcomes you desire. Just like a magnet, your thoughts have the power to pull things towards you. So, keep your mental magnet strong and positive.